Hi, everybody. Now we're doing section 2.1. This is what the real calculus now. And so first I wanted to say, what distinguishes calculus from algebra? Because you're going to see a lot of stuff we're doing is just going to be graphing and doing stuff. And, it's a lot of, like I said, most of what we're going to do this semester is really going to be algebra. So what is it that distinguishes calculus from algebra? What is it? And the answer is the concept of limits, the idea of a limit. In other words, well, let's just take a look here. Here we have a function, and f of negative 1.5. Now, here's looking at the x-axis. That's negative 1. That's negative 1.5. F of that, as you can see from the diagram, is 2. So I'm just going to type in 2. This is not calculus. This is not calculus yet. Okay. I wonder if there's any. Just curious if there's a. This question actually. I'll have to stop the share for a second. Hold on. I don't know what happened. All of a sudden, I lost my Harry Potter thing. I'll have to fix that later. Let me go back to share, and let's watch a movie. That's always fun. Let's watch a movie. So here we go. Video and pow. These movies I'm showing you are in Math Excel, and you can access them on your own anytime. Let's just take a look at it.
In this example, we're going to take a look at the graph of a function and try and determine the value of the function at some specific points. So here, we're asked to complete the following table using the given graph of the function g. So here's this line, and what we are asked to do is complete this table. So at negative 2, I'm going to go to my x value of negative 2, and I'm going to go up to my graph, and I'm going to notice that at negative 2, I appear to be about 1, 2, 3, about 4 units off the graph, or off the x-axis. So I'd say that the corresponding value of the function is 4. I do the same thing for 1. So at 1, I'm up at 1, 2, about 2.5. So I'm going to say 2.5. And then at 3, I go out 1, 2, 3 on my x-axis. I go up 1. It's about 1.5. And then finally, to figure out what's happening at 4, I go out 4, and it appears that my function passes through at 1. So now I've completed the table using the graph of the function.
Beautiful. That was very inspiring. The assignment to teach this course actually accepted by mistake because they said this is a document monkey business. I had no idea they meant like actual business. That was my first attempt to use it. Anyway, as I said, I will be teaching you, and you can write whatever you want, any pleasantry you want to write. Basically, what you have to write is just say what the question. And then when you click send, I'm going to get next time I go to my email, I'm going to see it. I want to really emphasize to you guys that I am an actual real human being, real person. Even though this is an online course, we're never going to be in the same room together. room or something? Oh, I can't believe it's been running the whole time. I didn't realize it. Okay, well, I'm gonna just continue. So, oopsie, I didn't realize I paused the wrong thing. Anyway, so here we have a question. Let's watch the oh boy, I just want to share again. Okay, let's try it one more time. Let's watch another movie. Yay.
In this example, we're going to be talking about the limit of a function. And to do this, we're actually going to have to analyze the graph. So it says here to analyze the limit, let f of x be equal to x plus 2. And it says to discuss the behavior of the values of f of x when x is close to 2. And that's kind of the key word here, close to 2. Now, we already know what's happening at 2. If we plug 2 into the function, we know we get 4. 2 plus 2 is 4. But what happens when we get closer and closer to 2? So I've got a graph here to look at. And in this graph, I'm going to highlight some things. Here's our graph of our function. F of x is x plus 2. Here's our line. And what we're going to do is we're going to pick some values that would get closer to 2. So here's 2. And we want to look at some values getting close to 2. So if you pick a value like about here and plug it into your function, you're going to wind up to being at this point on your graph. Now that corresponds to this value on your y-axis. So it looks like as I move closer to 2, like here, I'm getting closer and closer to the value of 4 up on the y-axis. Also, if I approach 2 from the other side, coming in, let's say a value right here, we go up to the graph, go over, and we can see we're about right here. And as I move closer to 2 from the right-hand side, I'm getting closer and closer again to the value of 4. That means that from the left and the right, it appears that as we approach 2, the function's value gets closer and closer to 4.
Okay, now you may say, like, what do I need all these dumb limits for? So I'm just making things unnecessarily complicated. So let's give an example of why we would need this. Now, okay, so let me show you some notation first of all. This reads the limit of the function f of x as x approaches 1. And what's that little negative sign? That means not negative. It doesn't mean -1. It means x approaches 1 from the negative direction. So here's the thing. Here's x equals 1 right there. And as I approach from the negative direction, f of x this whole time is equal to, can't even tell, is equal to 0. It's equal to 0. So now when I hit positive 1, I'm sorry, when I hit positive 1, the function jumps up, you know, to equaling 1. But the question is, what is it when I'm very close to it? Because so this function it's 1, it's 0, 0, 0, 0, 0, 0. So I'm going to put in 0. So from that direction it's 0. Okay. Now this is what if I approach 1, the number x equals 1 from the positive direction. Well, if I approach from the positive side, the y values are all 1. So as I approach the positive side, it equals 1. Now, here it says the limit is x approaches 1, and it doesn't have a positive or a negative. That means the overall limit. What's the overall limit as the x value approaches 1? Well, the answer to this is does not exist. And the reason is because the only time the overall limit exists is if the left-hand side and the right-hand side, I mean, when I say left, the negative side is the left and the positive side is the right. So it's only if I approach from both directions that I get to the same value, that's when a limit exists. But if I approach from one direction, it's a 1 value. If I approach from the other direction, it's a different value. That means the limit doesn't exist. And now, what is the actual function value? Now, the function value might not even have a function value. It happens to be that in this case, the actual function value is that solid dot right there, which is +1. So f of 1 actually equals +1. But even if see, that's an open circle, and that's a closed circle. So f1 equals 1. But what if they were both open circles? What if there was no what if there was no value at x equals 1? Well, it doesn't matter, because that's the beauty of limit. Even if the function is not defined at the point I'm looking at, as long as there are values getting close to that point, that's when I could talk about limits. And that's really the beauty of calculus. Calculus is very plucky. In other words, instead of saying, the function is not defined, doesn't matter. It may not be defined at the point, but as long as it's, we can get it's defined close to that point, we can get valuable information from it. Let's look at another example here. Okay, so here's a graph. We want to look at 3 from the. Okay, the limit is x approaches 3 from the negative direction. So if you notice, as the x values get closer and closer to 3, the y values get closer and closer to 2. I'm going to type in 2. And as here I'm crouching from the positive direction, and as the x values get closer to 3 from the positive direction, the y values also get closer to 2. So I'm going to type in a 2 again. And now, what is the overall limit? Well, since from one direction, since the answer is the same coming in from both directions, the overall limit is 2. And what's really cool about this one is that the function itself is not even defined at x equals 3. But the limit is, because even though the function is not defined when x equals 3, it is defined. The function is defined as I get close to 3. Now again, what's the big deal? Well, that's going to be a very big deal, because it means that even when something is not defined at that one point, we could still gain information about it based on what happens when we get close to that point. And that is going to be gold, because life is not always perfect, and sometimes you just got to get close, and that's a great thing. That's the difference between that's actually the difference between math and reality, I guess. So this is a little reality check. Let's see what this little video says. It might be the same video we saw already. I'm not sure. Sometimes when you see these videos, they're the same. Oh, I think this is one we saw already. Okay, so let's look at another one. Again, I want to just give you the idea here. These ones are boring here. Okay. Now, in this example here, as I approach x equals 2, well, if I approach from the left side, y is equal to 2 the whole time. If I approach from the right side, y is equal to 1 the whole time as I get closer and closer to point 2. So here I'm going to type in a 2, and for the next one, I'm going to type in a 1. And the limit, the overall limit, where there's no plus or minus, the overall limit is going to be does not exist, because since the left-hand side and the right-hand side, and the function value also does not exist, but that's just a coincidence. Whether the function value existed or didn't exist, still the limit would be the limit would not exist. That's really that's what it's all about. Okay, let's move on. Let's look at some of it. I don't want to pause. I don't want to pause this shit. I want to pause this. I paused the wrong thing before. Pause record. Okay, now for a different kind of a problem. This is very weird. Now for a different kind of a problem. Let's watch another movie. These are always fun to watch, and not just fun, but informative. Well, at least I consider them fun. You may or may not. For some reason, not everyone considers the same things equally fun. Let's see.
Let's look at some of the basic properties of limits. In this problem, we're going to use our limit properties to find the limit as x approaches 3 of x squared minus 4x. Now, to do this problem, we're going to use the fact that property 4 allows us to split a difference of two things into two limits. So I'm going to say limit x approaches 3 of x squared minus the limit as x approaches 3 of 4x. So that's property 4 from here to here. Now, using property 5 and property 6, I can take the limit of as x approaches 3 of x squared and break that into the product of two things. So x squared is x times x, so I break it into a product. And then I also use that property that allows me to take my constant 4 and pull it outside of the limit. So 4 times the limit as x approaches 3 of x. And now I can apply the limit to each piece. As x approaches 3, x approaches 3. So this becomes 3. As x approaches 3, x again approaches 3. Then we do minus 4 times the limit as x approaches 3 of x is also 3. And now we multiply here. 3 times 3 is 9. 9 minus 12. This gives us a result of negative 3. And you can check just by looking. If you would have plugged in 3 into the original expression, 3 squared is 9, minus 4 times 3 is 12. 9 minus 12 would give you a result of negative 3. And that's pretty intuitive, and that's how we'll do it in the future.
So you may wonder why did we bother? Why don't you just say it? Just plug it in. Why does it have to go through this whole rigmarole? The reason is because there will be times when you will not just be able to always plug it in and see if you get a nice answer, a simple answer, a number, 17, 3, whatever. But sometimes when you plug it in, you're going to get something undefined. You're going to want to get like a 0 on the bottom of a fraction or something. And that's when you have to go through this whole, more lengthy process. Okay, so let's just, now in this case, if I plug in 3, I just get 5 times 3, which is 15. So it's very simple. I'm sorry, not 3, 2. If I plug in 2, x equals 2, I just get 5 times 2, which is 10. And it's very straightforward. Pow. And these are all similar. They just plug in, no problem. The problem is going to be, all these are no problem. The problem is something like, this also will not be a problem. Where's it going to be a problem? 1. No, that's fine. Well, let's go back to this last one here. If you notice, the function is just a constant, -7. So it doesn't matter when x approaches. No matter what x approaches, this is always going to be -7. And this one here is always going to be +5, no matter what x approaches. So it really doesn't even matter. So this is really just going to be 8 times -7 plus +5. Which of them shows the correct? So it's 8 times and this is going to be 8 times -7. I'm going to type it in this way. Actually, let me put it over here. So, so it's going to be 8 times -7. 8 times -7. Oops. Plus +5, which equals -56 plus 5, which equals -51. And now I can't type. Now, if I try to enter this whole thing, it's going to tell me I'm wrong because the answer is just -51. Let's see what it says here. That's incorrect. So, because basically what happened was the math itself just couldn't read it because it's not what they're expecting. They're actually expecting just this right here. Boing. That's what they're expecting, and now it's right. Okay, let's just keep on going here. I want to find one that's really more challenging. Sketch puzzle. This is an interesting question. Instead of looking at a graph and figuring out limits, we're going to look at the limits and see which graph this could be referring to. So f of -1 equals 0. As x approaches -1 from the negative direction, it's -3, and as it approaches -1 from the positive direction, it's also -3. So which one would that be? Well, the only one that, which one would that be? X approaches -1. X approaches -1. I would say B. So when X approaches -1, we get, I think it's around -3. Oh no, f of -1 oh sorry, f of -1 equals 0. I'm sorry. F of -1 equals 0. And as it approaches -1, f of, I don't know, none of these look that great. Which one would it be? I want you to look at this and let's decide. Is it A, B, C, or D? The one that looks like it is B. And let's just check the answer and how. Let me just enlarge this a little bit. Okay, so this is the value of x equals -1. So f of -1 is 0 because that's the function. The y value is 0. But as I approach from either side, when I get close to x equals -1, the y values get very close to -3. That's why that's the answer. Okay, very nice. And let's these are all kind of same thing. Okay, x approaches 0, approaches 3. Okay. Here's where it starts getting interesting. Now, for this one here, if I just plug in x equals 0, I'm going to want it with 0 on the bottom of a fraction. That is not a good thing. That is not a good thing. So let's work this problem out. So it's x minus 3 over x squared minus 3x. So go here. Let's see, equation x minus 3. Here. So on top we have x minus 3. Oops. And on the bottom, we had x squared. Sorry, this is the best I could do. Minus 3x. For some reason, it's not letting me type the exponent. I don't know why. Oh, maybe I have to do it this way. Maybe I have to do it their way. Is this square? Bang. All right, so x squared minus 3x. So the first thing I'm going to have to do here is well, let me just type it again here. So let me just copy this whole thing. Let's do it over again. Another fraction bar. So what I'm going to do is on top, I'm going to have x minus 3. That's cool. On the bottom, what I'm going to do on the bottom now is I'm going to factor out the x. It's going to be x times x minus 3. And if you notice, what's going to happen now is that the x minus 3 is going to cancel. So I'm just going to have 1 over x. That's really going to be my final answer. Now, what happens when I plug in, 0 or anything like that? What's gonna happen here? That's something we have to consider. What's going to happen? Well, if I plug 1 over 0, if I plug 0 into the fraction 1 over x, it will be undefined. So it is going to be undefined. But if I plug 3 in, now see, if I plug 3 into the bottom here, I get 9 minus 9, which is 0. So you might think I'm going to say the limit doesn't exist, but since when I did the algebra over here, the x minus 3 is canceled and I'm left with 1 over x. Well, that means if I plug in 3, I'm just going to get 1/3. And if I plug in 9, well, that's just going to be 9 minus 3 divided by 81 minus 27. that's just going to be 9 minus 3. I'm just plugging it in over 81 minus 3 times 9 is 27. Which is, what does that equal? I don't know. Well, 9 minus 3 is 6. I'm pretty sure about that one. And 81 minus 27, I'm trying to do the, what is that? That's 51, 54? I think it's 54. And of course, which is really just 1/9. Now, I'm doing this in my head, so I'm not sure if it's going to be right, but let's see if I still can do this stuff in my head. Perfect. Oh wow, my brain still functions. How do you like that? All right, well, that's it. That was section 2.1, and that's it for this video. And we will see you guys next time. Bye, everybody. It's been a lot of fun.